Great day, learners. Welcome to EduSpark. Today we are going to talk about prime and composite numbers and prime factorization. Let's get started. Prime number is a number with only two factors, 1 and the number itself. Here are our examples: 5, 7, and 13. Okay, as what I've said, prime numbers they only have two factors, which is 1 and the number itself, just like 5. Factors of 5 are 1 and 5 only. Same as 7. Factors of 7 are 1 and 7 only, and also 13, its factors are 1 and 13 only. Now we'll move to composite number. Composite number is a number with more than two factors. We have 4, 8, and 12 as our examples. The factors of 4 are 1, 2, and 4. The factors of 8 are 1, 2, 4, and 8. The factors of 12 are 1, 2, 4, 6, and 12. Notice that the difference between the two prime and composite numbers is that prime only has two factors. We have number 1 and the number itself. While composite numbers, it actually has more than two factors. More than two factors. Now, in the table below, the numbers marked with blue are prime, while those that are not are composite. Now look at number 1 right here. It's not blue and it's not even white in color. So you could tell number 1 is neither prime nor composite because its only factor is 1. Okay. Now another, prime factorization. This is a process of expressing composite numbers as a product of their prime factors. Example, there are two ways of finding the prime factorization of a given number. First method, or a way of finding the prime factorization, is by using a factor tree, and the other is through the use of continuous division. Example, using the factor tree method or process in finding prime factorization. So say for example 16 is the given number. So you have there, since 16 is a composite number, you can actually look for factors of 16, and you have one of the factors is 4 and 4. So if you are to multiply these two, 4 times 4 is equal to 16. So you have 4. 4 is still divisible by 2, or can still be factored, or you could look for factors of 4. So you can have 2 times 2. If you are to multiply that, you'll get 4, same as the other one. 4, you have your factors of 4, which is 2 and 2. So therefore, the prime factorization of 16 is 2 times 2 times 2 times 2. If you are to multiply these, you should have the product of 16. So if you are to try that out, 2 times 2, that would give you 4. 4 times 2, that's 8. 8 times 2, it's 16. So this is correct. Now let's have the example for a continuous division. Same number being given out, it's still 16. 16 is an even number, is a composite number. You can actually, and this is also divisible by an even number. Say, for example, you could have 2. 16 divided by 2, that would give you 8. 8 is placed inside the symbol, and then 8 can still be, or there are still factors of 8. You can have 2. If you are to divide it by 2, you can have a quotient of 4. Or if you are to multiply 2 times 4, that will give you 8. So you have 2 on the outside, 4 on the inside. 4 is still divisible, or you can still look for factors of 4, which is 2 times 2. So 2 times 2 is equal to 4. Okay, then 2 in here, its factor or factors are only 2 and 1. So what is left? These are your prime factorization. 2 times 2 times 2 times 2. Notice that in any of the methods you are going to use, you can actually get the same answer. Okay, so let's give this a try, and you may get a scratch or a paper on or your notebook for you to try this out. And you may use our chat box for you to send down or comment down on the answers of these practices. 1, you're asked to use continuous division to express 90 as product of its prime factors, same as second is to use factor tree to express 12 as product of its prime factors. So again, 1, you're asked to use express 90 through the use of continuous division. Second is 12 using factor tree. Thank you, and see you on my next video.